Okay, this is section 3.5. This is a little bit different than the notes we've been taking. Um, the list you have is largely just vocabulary, and this is kind of an introduction to scatter plots, correlation, and lines of best fit. And then in the next section, we're actually going to apply some of these. So as a warm-up, I would like you to find the equation of the line through these points. Obviously, this is something that we're going to use in this section. So go ahead, you can stop the video and you can work, you can find the line in slope-intercept form that goes through these 2 points. Okay, so here is the broken down version of this. You find the slope by using the Weinglass formula, the y2 minus y1 over x2 minus x1. We found the slope to be 5/4. Then you take one of the points, and they use this point, and plug it back in to get your y-intercept or your b. So pretty fractiony here. Your final answer is y equals 5/4 x plus 2 1/4, or I like them improper better. That would be 9/4. Or for you decimal people, which you know how I feel about that, y equals 1 1/4 plus 2 1/4. Okay, so suppose we were looking at the number of years work compared to the annual salaries of a certain company, and we got these results in this table. There's a lot of numbers here. So, we can stare at this and look for trends, or, um, you can probably order the years worked and make that into a table and find the relationship. So how would you describe it? For your visual people, if we plot it on a scatter plot like this, and this is in a scatter plot, you don't draw lines, not yet, and it makes it a whole lot easier to see any relationship. Obviously, the longer you go over on the years worked, your salary creeps up at this company. So if you plot it on a graph, you can see the whole picture at one time instead of just one number at a time. So the first um, vocabulary word on your note sheet is scatter plot. It's just data that's plotted as points on a graph. Right there, you can write that down. Data that is plotted as points on a graph. That's your first definition. Um, this is I love this example because Old Faithful is one of my favorite places. Um, this is this is a scatter plot, a representation of data, and we can talk about data of anything like Old Faithful eruption, shoe sizes, anything. So it's not limited. All right. So does this scatter plot help us determine whether or not the quantities are related to each other? Yeah, because if you look at the direction the points are going, it's upward sloping, which means that, again, the longer you work, the more money you're going to make. So it's pretty helpful. Okay, so one of the things we can look at in a scatter plot is correlation, and that's your next word. Correlation is the pattern that we can see on a scatter plot. The patterns that we can see on a scatter plot. So you can fill in your next vocabulary word. So when we're talking about correlation, we're looking to see if it's either positive or negative. And these are the next two words on your list. A positive correlation exists when an increase in one variable corresponds to an increase in the other. And that makes it look like the pattern on your graph is going uphill. Again, positive correlation exists when an increase in one variable corresponds with an increase in the other, making it appear as if it's going uphill. The next word, negative correlation, exists when an increase in one variable corresponds to the decrease in another. And this makes your pattern appear to be going downhill. So that's a negative correlation. Okay, so we're going to, this is a great little graphic here. It shows you what a negative correlation looks like, a positive, and the one in the middle is zero correlation. There's nothing. You can't tell any patterns there, and you're going to see this. So the points are spread out, not showing any trend one way or another, and that does happen. Okay, so the other thing that we need to look at is the strength of the correlation. A strong correlation exists when the points are tightly squoze in and grouped in a straight line. That's strong. The correlation becomes weaker as the points spread out more. If the points are too spread out and you can't really see a pattern, again, that's that no correlation that I showed you in the center here, zero correlation. So strong correlation is your next vocabulary word, and it's when the points are tightly grouped around a straight line. A weaker correlation is when the points are more spread out. So that's your next two vocabulary words. All right. So this one on the upper left here would be a strong positive correlation because the points go uphill and they're pretty tight to a straight line. This is weaker positive. They're still going uphill, but the points are more spread out. This one is weaker positive. This would be a fairly strong up here, negative correlation. Points go downhill, they're fairly tight. This one on the bottom right here is no correlation. No correlation. You can't see a trend either up or down. So how would you describe this one? I would say it's uphill, so it's positive, and the points are tight together, so it's strong. This is a strong positive. This one obviously going downhill, points are still pretty tight, so I would call this a pretty strong negative correlation. This one is still negative, but it's weak because the points are spread out. So this is a weak negative correlation. Still going downhill, but they're pretty spread out. All right, so to help describe the pattern more directly, more specifically, we can create a line of best fit. It's some people call it a trend line, but we're mostly going to call it a line of best fit, which approximates the pattern in a data. So you can write this by line of best fit. It approximates the pattern of the data, and it's a line that is close to all of the points as possible, essentially going down the middle of the points. The hard part is my line of best fit may not be exactly the same as yours. So it's hard for you guys to realize my answer is not going to be exactly the same as yours. This is an approximation unless we do it in our graphing calculators, which we're going to do next lesson. So again, this is a line that you draw right down the middle of all of the points, and then you're going to find the equation to that line. Okay, so this is an example. We drew a line that follows the upward pattern and is between most of the lines. Sometimes there's an outlier. So here's what we can do. We can take 2 points on the line. So right here, this is 5 and 51,000 and 6 and 58,000. And from our warm up, we know what we can do with those 2 points. So you're going to find the slope using the 2 points. Let me write them down again. 5 and 51,000. And I already forgot what the other one is. 6 and 58,000. Okay, so we're going to use that wine glass formula to find the slope first. So I'm going to take 58,000 and subtract 51,000 over 6 minus 5, which gives me 7,000 over 1. So my slope is 7,000. Now we can use the points to find the y-intercept. So I have y equals 7,000x plus b. I'm going to take 51,000 equals 7,000 times 5 plus b. So I have 51,000 equals 35,000 plus b. I'm going to subtract that 35,000. And that will give me 16. So b is 16,000. So my equation is y equals 7,000x plus 16,000. All right, we're going to work more with that as we go along. Here's our summary. Recaps everything. When you're looking at real-world data, explore relationships. One strategy is to use a scatter plot, do a big picture. We can draw conclusions about the type of correlation that the data exhibits. We can connect algebra by approximating a line of best fit using 2 points and finding the equation. The equation allows us to describe, interpret, and predict aspects of the relationship based on the data, and we're going to do that in the next lesson. We're going to work on some worksheets together now, but that's it for notes.